Welcome to Notes 1.4, Transformations. We are looking at, this is just a library of parent functions, just to remind yourself, linear functions, no exponent other than 1 just for x. We've got a line. Absolute value functions gives us this v. Square root functions, quadratic functions, cubic functions to the third power, and we also have our rational functions here, which have like fractional indices. So just to remind yourself, like if a graph, any graph is shifting vertically up and down along the axis, if we're adding any number or subtracting any number to the end of that equation, it's going to move it up and down. Horizontally, to the right and the left, I call these guys the tricksters because they are inside of the parentheses, and the left makes it go horizontal. It's with the x, so that helps you remember it's going on the x-axis. And the plus is making it go to the left, actually. So the left negative makes it go right, positive makes it go left. That's that trickster. And the way I remember it is that these guys have parentheses around them, which makes it look like they're wearing a mask. People who wear a mask are never honest about who they are. We can't believe them, so they trick you. So that's just a little helpful hint to remember. So this one is saying that we have the graph of x cubed, but it asks us to do x cubed minus 1. So that means that it shifts down 1 unit. So we're literally drawing the same thing, but it's shifted down 1 unit. This one, trickster. So instead of going left like we would think, we go right. It tells us that it's with the x, so we know we're going horizontally. There's our x cubed function. X plus 2 tells us that we're going to go left 2 units there. And there we go. We've shifted up, down, left, right there. Oh, up into my notes, guys. Sorry about that. I think this is the next page here. Okay, so up next we're talking about each graph is a transformation of x squared. So this one's just asking us to think about it backwards and to actually write the function instead of writing the, drawing the graph. So like this one, it's a normal, the parent function was x squared, and this one actually shifted up 1, 2, 3, 4. So we know we just add that to the end of the function. We could include the g of x. X squared plus 4. This one has 2 shifts. It's going to move 2 to the left. So we would say x not minus plus 2 squared, and then minus 1 because we go down 1. So this tells us 2 to the left and 1 down. Okay, next one. Each graph is transformation on the graph of x squared. Write the equation for each function. So same thing here, but we're introducing another concept here that's a review. Negative reflects it along the x-axis. It just mirrors it like that if it's out front of the function. If it's a negative in with the x, that's when it reflects it across the y-axis, so the other way around. These were both reflected across the x-axis, so we're just making them negative. So we know this becomes negative x squared, but we also see that it shifted up 2. It'd be negative x squared plus 2. This one also facing downward. And another thing that you can do, I like these guys, I think they're so cute. Positive parabola, sad negative parabola. So you can remember which way that it faces. Happy face, sad face. Okay, negative x squared, but this one, I shouldn't have drawn my squared yet, because this guy is moving 3 to the right, trickster. So we keep it in there. It didn't shift up or down at all. So that would be all for our equation. These were f of x's, so I could keep them as f of x for my function notation. Okay, up next we have compare the graph of each function with the graph of f of x, the square root of x here. So it's saying what happened? The negative gives us a reflection in the x-axis, just like we talked about with our sad faces here. So this just flips it. The next thing that we see here is x square root of negative x. This is this thing here. It's inside with the x. So this is reflection along the y-axis. And this one has a couple things going on. We see the reflection on x axis. And we also see this plus 2. This is not in parentheses, but it's in the root, so we know that it's also a part of that trickster rule. So this is going to shift 2 to the left. Just a reminder that square root function looks something like this. And so if we were doing the reflection along the x-axis, it would flip like that. If we were reflecting along the y-axis, it would look like this. And then if it reflected along the x-axis and it shifted 2 to the left, it would look something like that. So that's kind of just the general what's going on in those graphs there. Okay, non-rigid transformations. So horizontal shifts, vertical reflections, those are all rigid transformations. They're just moving it up, down, left, right. It's very rigid. So non-rigid transformations are those that cause a distortion, a change in the shape of the original graph. For example, a non-rigid transformation of the graph f of x is represented where when we have this number that we're multiplying out front here, that's going to give us a vertical stretch. So it's stretching the function out further when c is greater than 1. But if it's less than 1, if it's a fraction, so if it's between 0 and 1, if it's a fraction less than 1, it is going to be a vertical shrink. So another non-rigid transformation is when we have it in with that c. So instead of it being vertical, it's going to be horizontal. But in this case, it's actually a shrink because remember, trickster. So if it's greater than 1, this one shrinks it, and it's in between there. Then it would stretch it. So they're flipped of each other just like they have been on our rigid transformations. So next we are going to look at the graphs of 3 absolute value of x and 1/3 absolute value of x with comparison to the absolute value of x graph. So our absolute value of x graph looks normal like this, right? And it actually is at 0.1111. That's what we're looking at for our absolute value function for x. When we have this 3 out front, that tells us that this is a number greater than 1. It's out front. It's going to be a vertical stretch. So what this is actually doing is instead of going up 1 over 1, because that's what's out front originally, 1 over 1, this is going up 3 over 1 for our first points here. And that gives us a direction on where our absolute value is going. That works for your parabolas as well. That rule of like being able to find that first point there. So let's look at this next guy here for 1/3. So we know this is the parent function, the purple one. That's just your normal absolute value function. But yet, if we want to go to 1/3, it's going to look a bit different. When we are looking at the 1/3 graph, it's actually a vertical shrink. So every value on that graph, it's getting shrunk. And so instead of going up 1 over 1, we're actually going up 1 over 3. We're following this 1/3 pattern. And that's our absolute value graph there. So that's kind of the difference between the stretches and the shrinks, and these rules would work for your other types of graphs as well. Okay, last question. Compare the graph of f of 1/2 x with the graph of f of x equals 2 minus x cubed. So we're comparing the two of them. So we're comparing this to this. So relative to the graph of 2 minus x cubed, this graph is a horizontal stretch. Because this guy, the 1/2, it's inside the x and it's between 0 and 1. But we're actually comparing, so we're just labeling it right now. This guy is a shift up 2. And then this tells us that we have a reflection. So when it's asking us to compare them with one another, we actually have to plug in, like we're looking at taking this h function and plugging it in to f of x is what it wants us to do. So we're taking, because see how it says f of 1/2 of x? We're taking that and we're plugging it in. So we're saying 2 minus 1/2 x of x cubed. Now that we have this, we can actually cube it. So 1/2 times 1/2 times 1/2 is 1/8 x. And we have this new function. So we're comparing these two graphs here. How are these different? Oops, I forgot my cubed. So they are the same thing except for this part. So in this part, that's also a horizontal stretch. So the only difference is that this one is a horizontal stretch by 1/8. And that's the difference between our two equations there. Thanks so much, guys.